Let's have a look at the chemistry of alcohols. Now, what is an alcohol? The answer, of course, is it has a particular functional group. A functional group is what gives the molecule its character. And in the case of alcohols, we're looking at a carbon chain with this functional group attached, the OH group, the hydroxyl group. Hydroxyl group. And most normal alcohols would only have one hydroxyl group, although you can have 2, 3, 4, they would be called dihydric, trihydric, but really we'll come to that later. The next question we have to ask is, how do we name alcohols? Naming alcohols. The important thing here is to indicate the position of the hydroxyl group. That only becomes a problem when the carbon chain reaches a certain length. For example, when we have 3 carbon atoms in a chain, there are 2 positions, either at the end of the chain, as in that case, or in the middle of the chain, here. When the hydroxyl group is on the first carbon atom in the chain, we would use the number 1 to indicate that. With 3 carbons here, we would call this propan 1-ol. It is, after all, propane with an alcohol group on the first carbon. This here, propan 2-ol. The word which relates these 2 structures is isomers. And they are isomers because although their structures are different, the formula is the same in both cases. Each molecule has the same number of carbon, hydrogen and oxygen atoms. It's only the position of the OH group which differs. Let's look at a slightly more challenging example. How about we take something like this? Here is a carbon chain with 2 branches. Let's put the OH group, the hydroxyl group, on this carbon here. How do we name this molecule? We have to give it a name which is unique to this particular structure. We look first of all for the longest carbon chain. There it is, 1, 2, 3, 4, 5 carbons. So this structure is based on pentane. The most important thing in this molecule, however, is not the branches, but the hydroxyl group. And to indicate its importance, we use the smallest number possible. We say that the hydroxyl group is on the is on the 2nd carbon atom in the chain. So we would number this long chain 1, 2, 3, 4, 5. We give priority, as I say, to the hydroxyl group, and that priority comes in giving it the smallest number possible. So this is basically pentane with a hydroxyl group in that position, pentan 2-ol. It's pentan 2-ol with these branches bolted on. Where are they? Well, there are 2 of them, and they're on carbon atom number 4. We can't call this one carbon atom number 2. This one is already carbon atom number 2. Dimethyl. 4,4-dimethyl. Pentan 2-ol. There we have it. 4,4-dimethyl. 4,4-dimethyl pentan 2-ol. Another aspect of alcohol chemistry which you need to know is how to make alcohol. The traditional method would be fermentation. However, there are problems associated with fermentation. First of all, it only gives ethanol. So we're kind of limited there. There are many more alcohols out there than ethanol. Other problems are that it's a slow process. It takes many days for the material to ferment. And also, there's a very low yield. Low yield. We end up with only a small percentage of ethanol. That isn't really very efficient. So we're really looking for something better than that. An alternative route would be this one. An alternative route would be to start with an alkene, and by adding water to the double bond, turn the alkene into an alcohol. This adding water to a double bond is an example of an addition reaction. This particular addition, this addition of water, is called hydration. And in this very simple example, when we add the water, the double bond opens up, part of the water ends up on one carbon atom, the rest of the water on the other one. Our OH, our hydroxyl group, tells us we have an alcohol, in this case ethanol, with its two carbon atoms. However, sometimes it's slightly more complicated than that. For example, if we had, let's say, this alkene, and this alkene is propene, then there are two ways in which the water could add on. You have to have your wits about you here. You have to be thinking, is there one answer or is there two? The water could add on across the double bond in this fashion, the H at the end and the OH in the middle. Alternatively, it could add on the other way round, with the H in the middle and the OH at the end. And from your point of view, it's 50-50. These are both likely outcomes. So, the hydration of propene produces two products. This adding water, this hydration, has created two different outcomes. Here we have propan 2-ol, and here we have propan